Right, good afternoon class for the second time after we now put 3D problems behind us for a week, and we will revisit it in a week's time. Okay, don't let me waste my time, and when we get there and you're still at the same point as which you find yourself today. Okay, alright, analytical geometry. So you have dealt with analytical geometry before in grade 10. That is when we spoke about your distances, your midpoints. In grade 11 we spoke about angle of inclination and equations of straight lines. What else is affiliated with analytical geometry? Gradients, no? A lot of gradients and parallel lines and things like that. So analytical geometry, in the introduction we are told, and this is on page, which page are we on? 188. You learned these analytical formula in grade 11. We spoke about the distances. Is x2 minus x1 squared plus y2 minus y1 squared. The gradient is change in y over change in x, which is x2 minus x1 over y2 minus y1 over x2 minus x1. Then you spoke about the midpoints of a line, which is x1 plus x2 over 2, y1 plus y2 over 2. Then we spoke about the angles of a straight line, the equation of a straight line, which will always be in the form of y is equal to mx plus c. Unless the line is parallel to the x-axis, which will have a y equals whatever it's going through, or it's parallel to y-axis, which will have an x equals whatever the point it's going through on your x-axis. Okay. The formula y minus y1 equals m into x minus x1. You can use that formula if you like, but we use the y is equal to mx plus c so often that we don't need another formula, because y is equal to mx plus c is enough, is sufficient for us. Okay. But as I said, if you want to use the other formula, or somebody else taught you to use the other formula, no problem. We know how to mark it. Okay. You found to find the angle of inclination, we need to use the formula tan of theta is equal to your gradient. Okay, those are the formula that we've dealt with thus far. Also, these formulas are on your formula sheet. Okay. Did you get the formula sheet at the end of last year? Sorry? Didn't I give you a formula sheet when you wrote maths at the end of last year? So you didn't write your grade 11 exam with a formula sheet? You did? Oh. And everybody has a copy now. No? Who needs a copy of the formula sheet? I'm selling 5 rand a copy. No. Oh, you guys can't laugh. Yeah, I get surprised by you guys every day. But anyway, if you need a formula sheet, you let me know. I have one here for you. Okay. So now consider the general formula for a circle. So analytical geometry is 30 marks, 30 or 35 marks in your final exam. 10 marks is on the circles, the rest is all on grade 11 geometry. Okay. So if you did well in grade 11 geometry, you will do well in this section as well. Okay. So there's two types of circles. Okay. The circle where the center is at the origin. Okay, you got the circle and the midpoint, or not the midpoint, the center point of that circle is at the origin. Okay, so we have a circle. That center of that circle is at the origin, or where the two axes of symmetry meet. Okay, not axis of symmetry, sorry. Your axis in your Cartesian plane meets. Okay. Then we have a circle where the center is not at the origin. Okay. And of course it will have a different equation. Okay. So we are told that the circle that are centered at the origin, let the origin of the circle be point x and y, be any point on the circumference of the circle with radius r. So we are given that point there, which is x and y. According to the distance formula, we can say that r, how do we work out the distance? Square root of x minus 0 squared plus y minus 0 squared. That is how we do the distance formula, not so? So x minus 0 squared is going to give you x squared, y minus 0 squared is y squared is equal to r squared, not so? Not r squared but r, sorry. You just say yes. So to get rid of the square root, what do? Square both sides. That means you say therefore x squared plus y squared is equal to r squared. Okay. So that I want you to put there in the box. Circles that are centered at the origin. Your formula is x squared plus y squared is equal to r squared. Okay. Okay. Therefore, the equation of the circle was center at 0 and 0, and the radius r is x squared plus y squared is equal to r squared. Okay. Then we are given circles that are centered off the origin, or the circle where center is not at the origin. Okay. We are told to let the center of the circle be point A and B, and point x and y be any point on the circumference of the circle with radius r. According to the distance formula, we apply distance formula here. R squared is equal to, not r squared, I'm thinking of the answer already. R is equal to, using the distance formula, x minus a squared plus y minus b squared. Okay? To get rid of the square root, I square both sides. Not so? So in other words, the equation of the circle centered off the origin will follow the formula x minus a squared plus y minus b squared is equal to r squared. So circles that are centered off the origin follows that formula. Therefore, the equation of the circle with center AB and the radius r is x minus a squared plus y minus b squared is equal to r squared. To find the equation of the circle, you must first know the center and the radius of the circle. Okay. You all okay with that? So there's two formulas that is given to you with regards to analytical geometry. Those formulas are on the formula sheet as well, correct? For those of you seeing the formula sheet for the first time, this term, check if it's on there. Do you see it there? It is under the equation of the straight line y is equal to mx plus c. You see below that? You got x minus a all squared plus y minus b all squared is equal to r squared. Okay. So let's look at a couple examples, and these examples are on page 189. Page 189. The question says determine the equation of a circle, of the circle or circle's width. In the first case, the center as the origin and passing through the point -5 and -7. So what we have here, you got the circle. Circle is going from the origin and is passing through this point -5 and -7. Okay. So which of the two formulas are we going to use? Sorry? First one, x squared plus y squared is equal to r squared. So what needs to be determined here to determine the equation of the circle? We just need to calculate r. Not so? So how do we calculate r? By substituting x and a y. Not so? Do we have an x and a y in the circle? Yes. -5 and -7. So do your thing there quickly. So what do we get? -5 squared plus -7 squared is equal to r squared. So it's going to give us 25 plus 49 equals r squared. So r squared works out to be, sorry? 74. I'm not going to take the square root. Why? Because I need to know what r squared is anyway. So if we're going to square root it, we're going to square it again. So we don't square root it. So therefore the equation is x squared plus y squared is equal to 74. Is anybody that's confused here? No? Right, let's look at number 2. In number 2 we are told center. So we got the circle. The center of that circle is -3 and 5, and it has a radius of 7. The radius is 7. So which formula are we going to use here? Second one, which is x minus a squared plus y minus b squared is equal to Awesome. So what's your A value? Huh? -3. What's your B value? Huh? 5. And your R value? 7. So do the substitution. So what do we get? We got x minus minus 3 becomes plus 3 squared plus y minus 5 squared is equal to 7 squared. What is 7 squared? Huh? 49. Okay. You can multiply it out if you want, but no extra marks. Okay. And as we know ourselves, we don't want to do extra. We don't want to even do the minimum. No? Okay, any confusion here? Any confusion, people? No. Let's look at number 3. Number 3. Another circle, yes? You got A, the diameter AB, where A is 2 and negative 4, and B is negative 2 and 10. Determine the equation of the circle's width, the diameter AB, where A is 2 and negative 4, and B is negative 2 and 10. Which one of the two formulas are we going to use? Is the center at the origin? Partially, no? How do you know the center is at the origin? We don't. We don't know that. How are we going to calculate the center? Huh? Say it. Midpoint is. Why midpoint? The radius are equal. Not so. So work out the center of the circle for me. Using the midpoint formula. How do I get to C? So it will be x1 plus x2 over 2, y1 plus y2 over 2. So what do we get? 2 plus negative 2 over 2, and negative 4 plus 10 over 2. So your C works out to be 0 and 3. So is the C at the center? No. Is the center at the origin? So which formula are we going to use? Second one. We use the second formula, which is x minus a squared plus y minus b squared is equal to r squared. So what do I have? This value here is what? An A and a B, not so? Why? Because that's your center. Okay, that will never be an X and a Y for that formula we're using. There will always be the A and the B. Okay? So what's the equation going to read now? X minus 0 squared plus y minus 3 squared is equal to So for this formula, what do I still need to determine? R. And how are we going to calculate R? By either substituting A in, the coordinates of A, or you're going to substitute the coordinates of B. One of the two. So which one you want to substitute in? Let's substitute A. So you're going to get 2 and negative 4. Remember now, this is an X and a Y. If it's on the circumference of the circle, it's an X and a Y. If it's the center of the circle, it's your A and a B. Not so? Do the substitution quickly. So what do we get? 2 minus 0 squared plus negative 4 minus 3 squared is equal to R squared. So 2 squared is 4. 7 squared is 49. 49 plus 4? 53. You all get that? So what's the equation of the circle? X minus 0. What is x minus 0? X minus 0 is? X, yes. So that will remain x squared. You understand? It's x squared plus y minus 3 squared is equal to 50. Alright? You guys understand? Ja, mijn bro. You look at number 4. An x-intercept of 2 and 0, and a y-intercept of 0 and 6, and a radius of 2 root 5. So let's see what's happening. An x-intercept of 2 and 0, and the y-intercept of 0 and 6. Or it could have been here or whatever. Okay. And as a radius of 2 root 5. So which formula are we going to use here? It has to be the second one. Okay, so it's going to be x minus a squared plus y minus b squared is equal to r squared. So at this point, what do we have? We have an x and a y, two of those points is? We have the radius. That's all. So what's it? The radius is going to be 2 root 5, not so. So that's going to be 2 root 5 squared So what I'm going to do is I'm going to substitute. So that's x minus a squared plus y minus b squared is equal to 2 root 5 squared. So what still needs to be solved here? Your a and your b. Not so. So what I'm going to do is I'm going to substitute 0 and 6. Substitute 0 and 6 quickly. See what you get. Okay, so what do we get? 0 minus a squared plus 6 minus b squared is equal to 4 times 5 is 20. So this is simply a squared plus b squared minus 12b plus 36 is equal to 20. Okay. So in other words, a squared plus b squared is equal to 12b minus, what's 20 minus 36? 16. This is equation 1. You will agree with that? Now we do the same and you substitute 2 and 0 into the same equation. Okay? So what we're going to get now is 2 minus a squared plus 0 minus b squared is equal to, again, 2 root 5 squared, which is 20. So that gives us, I'm just going to go a bit faster through it. That's going to give us 4 minus 4a plus a squared plus b squared equals 20. So a squared plus b squared equals 4a plus 16. The reason why I did that was because this is going to be a compound substitution here. Okay? Because I've got a squared plus b squared on either side of the equal sign. So if a squared plus b squared is 12b minus 16, and a squared plus b squared is 4a minus 16, this is what I'm talking about, then we have to conclude that 12b minus 16 has to be equal to 4a plus 16. Okay? So what I'm going to do is I'm going to make a the subject of the formula, so 4a is equal to 12b minus 32 divided by 4, so I got 3b minus 8. And this is equation 3. Okay. So what we do with this is we substitute this back into any one of the previous equations, either 1 or 2. Okay? So that's now going to give us, let's go with equation 1. So wherever there's an a, I'm going to put a 3b minus 8. So So 3b minus 8 squared plus b squared. Yes? Sorry? You took that over? No, you didn't take it. You kept that here. So it's going to be 12b we're keeping 4a on this side of the equal sign. So it's going to be 12b minus 16 is minus 32. Yeah. Okay. So that's simply going to be 3b minus 8 all squared plus b squared is equal to 12b minus 16. Which now gives me 9b squared. That's 48b plus 64 plus b squared equals 12b minus 16. So that's going to give us 10b squared. 48 minus 12 is minus 60b. 64 plus 16. What's 64 plus 16? Sorry? 80 equals 0. Okay, work out that value actually, please. It's 8, you're going to be 4 and 2. So that's the values for B, which is going to be from the center here. That is A and B. So B can be any of those two values. Okay? But how do we solve for A? Wherever B is, I put a 4. So 3 times 4 minus 8. 3 times 4 is 12, and 12 minus 8 is 4. On the other hand, A is equal to 3 times 2 minus 8, which is 6 minus 8, which is negative 2. Now to answer the question was, what is the equation of the circle? So the equation of the circle is going to be x minus a. I'm going with these two here. X minus a, so it's minus 4 squared, plus y minus b, which is also 4 squared, is equal to r squared, which is 2 root 5, all squared, which is 20. On the other hand, we got x minus a, which is minus 2, plus 2 squared, plus y minus b, which is negative 2 squared. I'm using these values for a and b now, equals 2 root 5 squared, which is again 20. So it's either one of these two. Okay? For homework, I want you guys to do exercise 1 on page 192. You do number 2. Okay. There are 8 sums there, similar to what we did today. People enjoy the rest of your day. Good morning. Good afternoon, class. Don't forget the sign, cost, and area videos. Oh, I thought at the end of the day.